Now that we've done a few examples of graphing quadratics, we want to be able to write the equation of the quadratic. So if you remember that the graphing form is y equals a times x minus h squared plus k. So the first thing that you should be able to do is write the equation for a parabola given various information. So here I have my vertex, h and k, and then my a value. So I can plug those right into my equation. My a value, x minus 0, I don't need to put that in, and then plus k. So my equation would be 3x squared plus 5. Now I'm going to do another example. My vertex here is h and k, and my a value is minus 2. So again, I'm going to plug those in to their spots in the equation. Y equals minus 2, x plus 7, remember, opposite sign, squared, and then minus 4 for my k value. So now we're going to extend our definition a little bit, and I'm going to give you the information that what my parabola that I'm looking for is congruent to y equals 7x squared. That means that they have the same a value. So congruent is same a value, just like parallel lines. So here we go as y equals 7. So I've got my a value. Now I need my h and k. It has a maximum at 3 minus 4. So that tells me that my parabola has to open down, which means my 7 has to be negative. And then my maximum just tells me my vertex. So x minus 3 squared minus 4. Let's try another example. So this one tells me that it's congruent to y equals minus 3x squared. So that means that my a value is 3. The second part of the equation says that it has a minimum at 2 minus 9. Minimum means that my parabola is going to be opening up like this. So I know my a value is positive, and then I can plug in the values of my vertex. So a, x minus 2 squared minus 9. Now we're going to look at finding one of the values if we're given a point on the parabola. So this question asks us to find the value of k so that the parabola y equals 4x squared plus k passes through this point. Just like when you were finding the y-intercept for y equals mx plus b form, we're going to take our values and plug them into our equation. So we've got 20 for y, minus 3 for x, and then we're solving for our k value. So we've got 24 times 9 plus k. 20 minus 36 equals k. So k is going to be equal to minus 16. The next example that we're going to do is find the equation for the parabola with vertex minus 4, 2, and passing through minus 830. So I'm going to start off by substituting in what I know. I'm not sure about my a value. I know what my vertex is. So I know my h and my k. Now the one that I'm solving for is my a value. Since I know a point, I'm going to take those values and substitute them in for my x and my y. And then whereas in number 2, I was solving for k, now I'm going to solve for a. So the first thing that I'll do is move the 2 over. So I've got minus 32 equals a. Then I'll do some simplification here. So minus 4 squared is going to give me 16. So that means that a has to equal minus 2. So I'm not done because the question asked me to find the equation for the parabola. So I'm going to summarize by rewriting my equation with the value for a in there. Okay. The last example that we're going to do is find two parameters. So I've got my parabola here. I know the x-coordinate of my vertex, and I know 2 points. So I'm going to start off by substituting in one of my points here. So let's do 2 and minus 7 first. So a 2 minus 4 squared plus k. And now I'm going to simplify as much as I can. So I've got 4a plus k. And then I'm going to do the same thing with my second point. So minus 70 equals a minus 1 minus 4 squared plus k. Maybe see where this is going at this point. But minus 5 squared, so 25a plus k. So now I've got two equations and two unknowns, and now I can solve them. So if I'm looking here, I've got 4a and 25a, those coefficients aren't the same, but my k's both have a coefficient of 1. So what I'm going to do is I'm going to write my equations over here. So I've got minus 7 equals 4a plus k. That's my equation 1. And then in my equation 2 is minus 70 equals 25a plus k. There's my equation 2. And then I'm going to subtract these equations to eliminate k. So now I've got minus 70 minus 70, which is going to give me positive 63. And then I've got 4a minus 25a, which is going to give me minus 21a. So now I can solve for a. And I'm going to get a is equal to minus 3. Works out nicely. And now I can substitute a equals minus 3 into my first equation just because the numbers are smaller. So 4 times minus 3 plus k. Minus 7 equals minus 12 plus k. K is going to equal positive 5. Okay. So therefore, I found my a and k values are minus 3 and 5, which is what the question was asking me. Some examples of how to write equations of quadratics given different amounts of information.